No. Coming back to physics. The third type of motion we are going to, so this the second type of motion that we are going to discuss is vibratory or oscillatory motion. So what do we mean by that? The name is suggesting. If there is a to and fro motion taking place about
fixed point, sir.
The fixed point. That fixed point has a technical name. About a mean position is called vibratory or oscillatory motion. So how is it going to look like? If I take a particle, if I call it as the mean position, okay, from the mean position, the particle will go to extreme, and this side it will go to another extreme, right? So when the particle travels to and fro, okay, from one extreme to another, then this kind of a motion is what is called as oscillatory or vibratory motion. And this mean position is what is called as fixed point. What is the example for this? The best example we can think of here is again.
Swing, sir.
Sorry?
Swing.
Spring. Yeah, spring is also an example.
The swing,
vibrating. Swing is also an example. Swing is an example. Spring is also an example. The spring which is vibrating, okay? The swing which is oscillating. Okay? We call it as either vibratory motion or oscillatory motion. Is it clear?
Yes, sir.
Yes.
Okay, now listen. So with respect to the oscillatory motion, there are other parts you need to understand. Like I told you, extreme position, but we do not call them as extreme position. We have some name for the distance between the mean position and extreme position. Do you know what is the answer for that? We call it as amplitude A. So amplitude of an oscillatory motion. So how do we define it? It is the maximum distance of the particle from mean position. So maximum distance of the particle from the mean position is what is called as amplitude. And it is represented with symbol A. It can be both positive and negative. In the sense, for example, you're taking the right side position to be A, the left side's maximum position will be minus A. Clear? So these are all the terms related to oscillatory motion. Okay, next. Time period. So how do you define the time period as? Time taken by the particle to complete one oscillation. So time taken by the particle to complete one oscillation is what is called as time period, and time period is represented by the symbol capital T. Clear?
Yes, sir.
Now listen. So when the particle goes from mean position to extreme and the extreme on other side, when can you say the oscillation is one complete oscillation? That is when, if I take this point as O, this as A, and this as B, one full oscillation or one complete oscillation is given like this. O to A plus A to O, right? So from mean to extreme and from extreme to mean plus O to B plus B to O. All these distances put together is what we call it as one oscillation. Guys, are you able to understand? So time taken for the particle to go from mean position to extreme is equal to how much? So time taken to complete the distance traveled by distance traveled between O to A to O, O to B, and B to O is what is equal to capital T. That is the total time. So it is broken into how many cycles?
4.
So 4, no? So time taken by the particle to go from mean position to the extreme is T by 4. From extreme to mean will be how much?
2.
So from mean to extreme, if it is taking T by 4, from extreme to mean also it will take the same time T by 4. Okay. Now where is the particle? The particle has gone to one extreme and come back. Now what is its work? From mean to other extreme will be how much?
T by 4.
Yes. So other extreme to mean is T by 4. This is a very important point. Have this in your mind. So the each journey is broken into 4 equal parts. Okay. The 4 equal parts put together is going to give you one complete oscillation. Clear, guys?
Yes, sir.
Right. Okay. Make a note of this.
So we should add all these, sir.
If you add all these times together, then you will get a total time of T. Is that clear? So that is what is meant by one full oscillation. Because the problems will have these kind of terms. The time taken by the particle is this much to complete one oscillation, or they will say 3/4 of the oscillation. So you need to have clarity. Suppose I frame a question from this. How much is the time taken for the particle to complete 3/4 of the oscillations? What will you say?
Three T by 4.
3T by 4. Suppose I ask a question, how much is the time taken by the particle to complete half oscillation?
T/2.
T/2. Suppose they ask what is for 1/8 of the oscillation. It will be T/8, that's it. Okay. Something like this. So they'll give you the times, don't worry. That's how we need to solve. So if you're clear with time period, the next point that we need to discuss is frequency. So frequency is given by the symbol F. What is frequency? It is the reciprocal of time period, that is mathematically. So F is equal to 1 by T. In terms of definition, it is like this: number of oscillations per unit time. So number of oscillations per unit time is also called as frequency. So what is going to be the SI unit for it?
Hertz.
It is actually second inverse, or we call it as hertz. That is Hz. Okay. Is this clear, guys? So we call it as second inverse or hertz. So these are all the main. So these are all the main terms that are related to oscillatory motion.